Hi everyone, welcome. This is my first attempt using the Google Hangouts feature for YouTube Live. I'm kind of excited about it. I'm sorry for the shaky camera work. I'm having to hold my webcam. I don't have a really nice place to put it right now. And then I'm going to kill the camera for a little bit and then fix it so that way it shows the paper that I'm going to be working on, which is right down here on my desk. So I'll get started in just a couple of moments. I've broadcasted that this should be started at 8:30. We're a few minutes before. I just want to make sure that everything's up and running, and I'm waiting for a couple of viewers to show up. So we will get started as soon as it turns. I'll give them a couple minutes. So about 8:40 or so. That's in about 13 minutes from now. So if you're just tuning in, stay with us. You get to see me, all the funny faces I make as I look around my screen and do stuff. So yay for hanging out with me. Thanks for joining me on this wonderful Wednesday night on a Wednesday webcast. Appreciate you joining in. And if you're watching this after the stream has gone live and you're one of my students, thank you so much. Be ready to take notes. I'm actually going to get ahead. Let me try that again. I'm actually going to go ahead and get started at 8:30. That's in 2 minutes. So those of you who are tuning in after the fact don't have to wait so long. Don't have to fast forward so much. So we'll be starting in about 2 minutes. 2 minutes of silence and dead air. This is super exciting. There we go. I see that this live event is now live on my YouTube channel. I'm so excited. This is actually working out. Yay! Oh, and I did notice, those of you who are looking at it, I did notice that my triangle congruence part 1 lecture video is showing only 1 second long. I'm not sure what that's about, so I'll be fixing that hopefully tonight. If not, then tomorrow. If you'd like to remind me that I need to fix that, that would be awesome. I appreciate you. All right, it's 8:30. I'm going to go ahead and turn the camera off just for a moment so that way I can show my note paper and we can get started on tonight's proofs. Okay, in case you can't tell, I have my webcam attached to the top of my head right now. So I kind of feel a little bit like a miner, like someone who digs around in the ground looking for precious metals or precious proofs. So there we go. And I'm going to try to keep my head really still so that way you can write this. This is not the best setup in the world, but it's what I have got for now. So we're going to be doing some proof writing. We're going to be doing figuring out what this means, this CPCTC thing. And we're going to be talking a little bit about what this HL thing stands for. I'm going to go ahead and put today's date on when the recording I did, and then we'll do that this was a live webcast. All right, pause the video now so that way you can get the objective. I will write proofs using this CPCTC and HL thing. All right. Here we go. Let's start off with the first proof. All right, hopefully I got this going here. Our first proof is given triangle LMN is an isosceles triangle with vertex M. Oh, and I promised to turn on my phone to check for some text messages. Okay, my phone is next to me. The volume is on. Haven't seen any text messages come in yet. So if you're watching and you have a question, please feel free to send me a text message. I'll be happy to work on that. Okay, so given this triangle, we're also going to be given that line segment MP bisects line segments LN. And with those two pieces of information, we want to prove triangle LMP, I'm sorry, not triangle, angle LMP is congruent to angle NMP. Okay, pause the video right now if you're not watching live so that you can jot that down. All right, we're going to go ahead and draw the diagram of this thing. I didn't bring one of my rulers home with me, so I'm just going to have to freehand this triangle. It's going to look something like this. L, M up here's the vertex, there's N, and P's down here. All right, I'm going to start by adding to my picture, my diagram, things that I know from what was given. The first thing that I know is that this line MP bisects or cuts in half this line LN, which means that this side here has the same measure as this side. They're congruent. Okay, so again, I'm going to take my little notes and I'm going to make all of my notes here on the diagram, and I can use that to do my two-column proof later. This is that definition of bisector. Definition of bisect. I also know because of this that because this, wait, I was trying to say that this angle is a 90-degree angle right here, but I don't know that because all I know is that this cuts this line in half. I don't know at what angle this line is coming at. Now, I know what you're thinking, but Miss Carranza, it totally looks like a right angle. Even with your terrible drawing skills, it totally looks like a right angle. Remember, we can't use, oh, that's what it looks like as a reason. But I can say that this side of the big triangle right here, LM, is congruent to this side of the triangle over here, MN, because I was told the very first thing was that that triangle is an isosceles triangle and that that point M on top is the vertex. And the definition of isosceles triangle says that the legs that come off of the vertex, they're congruent to each other. So now I have two sides. We're going to use our, oh, I need to mark this down. I wrote this because the definition of isosceles. And now I can use my dear friend, the reflexive property for this line right in here. Remember that reflexive property from Monday was the first time we had seen it really. Allowed us to say that a thing is congruent to itself. And so since this line here in the middle of our isosceles triangle is one side of this triangle on the left, and this line, the same one, is also a side of the triangle on the right, it's congruent to itself. But now we have it so that it's this side for this triangle is congruent to this side of this triangle. And now we have our side, side, side triangle congruence. I know that these two triangles are congruent. But that's not what we're trying to prove. Notice what we're trying to prove is not that the triangles are congruent, but that these angles, L, M, P, this angle right in here, and N, M, P, this angle right in here, we want to know if those angles are congruent or not. But here's the thing. This funny looking thing up here in our title and our objective, CPCTC, stands for corresponding parts of congruent triangles are congruent. Basically says that if I've got two shapes that are the same size and the same shape, the parts that line up with each other are gonna be congruent also. I know it totally makes sense and is one of those dumb moments, but again, with proofwriting, we have to be really specific about how we say it. And this shows me just how much I move my head when I talk. So I'm going to go ahead and try to keep my head super still, and I'm going to start writing that 2-column proof, because now that I have the triangles congruent by side, 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 triangles are congruent, I can use corresponding parts of congruent triangles are congruent, CPCTC, to say that this angle is congruent to this angle. So here we go. Going to start my 2-column proof off. Statements and reasons. When writing proofs, always start with your given. I was given the triangle LMN is isosceles. I was also told its vertex. And I was given line segment NP bisects line segments LN. And all of that was the given. Okay. The next thing that I could kind of go with any of these really. Okay, so I'm going to start with the one congruent. First little hash mark. Line segment LP, line segment LP is congruent to line segment NP. And that was by the definition of bisector. Definition of bisector. Okay. The next thing, I see the 2 hash marks. That must have come second, so I'm going to go ahead and do that one. That line is going to read that this line segment, L to M, is congruent to this line segment, N to M. And the reason is the definition of isosceles triangle. I didn't write it all the way. So we're going to go ahead and write that. Line segments. Oh, yeah, you can still see it. MN is congruent to line segments MN by definition of, bless you, sweetheart, isosceles triangle. Okay. If you're viewing this off of the archive on my channel, pause now so that you can catch up. Okay. Going to continue with our next statement. Going to use this third one right here, the one with the 3 little hash marks. This was congruent because of the reflexive property. That property said that the property that says that a thing is congruent to itself. So that would be line segment MP is congruent to line segment MP. And the reason is the reflexive property. Okay, if you're watching on the archive, pause it now so you can catch up. Oh, excuse me. Okay, we have now that the triangles LMP and NMP are now congruent to each other. And notice it didn't say anything about these 2 angles here. They totally look 90 degrees, but I don't really know. Okay, I don't really know. But I know now that these 2 triangles are congruent because of side, side, side. So that's what we're going to write right here. Triangle LMP is congruent to triangle NMP by side, side, side triangle congruence. And now that the triangles are congruent, I know that those angles that I was interested in are congruent. And that's by corresponding parts of congruent triangles are congruent. And this is what I was interested in. And so my 2-column proof is done. Pause it right now, and while you do that, I'm going to check my text message. Oh, it wasn't a text message from you guys. It was just my video game. Okay, so there's a proof using the corresponding parts of congruent triangles are congruent. Really fancy way of saying something that we already knew to begin with. Okay, this is the point where I put my bar, my break, and we're going to go on to something a little different. And this one is just a comment on what HL stands for. HL stands for hypotenuse leg. And for this to make complete sense, we need to do a little bit of triangle geography. Anatomy? Triangle anatomy, kind of like we did before. Please take a moment to draw yourself a right triangle. If you happen to have a ruler or some other straight edge and you want to make these lines really straight, you're more than welcome to. Make sure you mark the right angle. Not only the correct one, but mark the one that's 90 degrees, please. The side that is directly opposite the right angle, which means if I took a little squiggly line and I drew it from the vertex through the box marking the right angle, and I went through the corner there, and I just went to the side that's opposite it, this side right here that I would run into would be called the hypotenuse. We're going to go more in depth about right triangles very, very soon. So these little bits of anatomy are going to become very important. So I want you to jot it down right now and be able to refer back to this later. These other sides here are going to be called the legs. So there's one leg. Here's the other leg. So this right triangle has two legs and a hypotenuse. And what the hypotenuse leg triangle congruence says, triangle congruence, what this congruence says is that right triangles are congruent if their hypotenuse and one leg are congruent. I'm going to write that now that I've said it. Two right triangles are congruent if they if hang on, sorry, if the hypotenuse and a leg, any leg, are congruent if the hypotenuse and a leg, hang on, if a hypotenuse and a leg of one triangle, got to be really specific, is congruent to, there we go, this is what I'm trying to say, is congruent to the hypotenuse and leg of the other. Okay, pause it now, catch up with that. All right, so let's take a look at some pictures of what this might look like. So some visual examples. You might see a right triangle here and another right triangle sitting over here. And if you have the hypotenuses congruent and any leg congruent, then they are congruent. Okay, be the same thing if it had been one of these others. Now, I'm not going to get into the reason as to why this is true. Not yet, anyway. But I just wanted to introduce it and to tell you and to remind you that in our proofs, this triangle congruence theorem, this hypotenuse leg, is going to work for you much the same way side, 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 or side, angle, side, or angle, side, angle, or any of those worked for you. If you can get the picture to look like this, a right triangle, the hypotenuse is congruent, and one of the legs congruent, then you can say that these two triangles were congruent. And if what you're trying to prove is one of the angles of the other side congruent, the other leg congruent, then you can use what we did up here, that CPCTC, the corresponding parts of congruent triangles are congruent, to say that those pieces that you were looking for were also congruent. So that was the lecture presentation that I had for you that we were not able to get to today during class time. And just like I like to end my class, there's a quick look at the full page. I'll have this available in the classroom for you guys tomorrow if you want to take a quick picture of it with your cell phones tomorrow so you can copy it and add it to your notes. And I didn't see any viewers pop in, but that's okay. Thank you so much for joining me this evening. Sorry for the bouncy head cam. It was the best thing that I could do to show me writing as I'm writing the way we're used to doing in lecture. And thank you so much for coming on this exploration using Google Plus's Hangouts on YouTube live event. It's been a real blast and a real joy to work with you guys, and hopefully we can do some more of these again soon. Thanks. Have a great night.